Today we are going to see mass relationship, mass-volume relationship and volume-volume relationship. So what is the meaning of mass? When your mass of one component given and asking the mass of other component in a reaction, that time we call as mass. When what is mass volume? Mass of any one component given, asking the volume of other, that is mass volume. Volume of one component given, asking the volume of other, that is volume relationship. For the calculation of mass, volume, we have the three key points. We must follow these three key points. What is the first key point? The reaction must be balanced. So this is our reaction. First we have to check whether our reaction is balanced or not. No, this is not a balanced reaction. We can clearly see here we have 4 hydrogen, this side we have 2 hydrogen. So this side we have 2 oxygen, this side we have 3 oxygen. So first balance the hydrogen. It is 4, it is 2, that's why we will multiply by 2. Hydrogen is not balanced. Now check for oxygen. Oxygen is not balanced now. This side we have 4, this side we have 2. So we have to multiply by 2. Now oxygen is balanced. Our first target is complete. That reaction must be balanced. Our reaction is balanced. Second point is that the ratio of stoichiometry is the mole ratio. What is the meaning of stoichiometry? For a balanced chemical reaction, the coefficient of the component are called as stoichiometry. For this, the mole ratio is, we can say that 1 mole of this require 2 mole of oxygen will produce 1 mole of carbon dioxide and will produce 2 mole of water. Now we can check what is the mole ratio. 1:2, 2:1, 1:2 because our stoichiometry ratio is the 1:2, 2:1, 1:2. Now we have to, third point is that the ratio of stoichiometry is volume ratio. For gaseous component only, we can say that this is the gaseous component, gaseous product, and this is gaseous reactant. For gaseous component only, the ratio of stoichiometry is the volume ratio. Now this is the question. In burning the CH4 in the presence of 44.8 liter of oxygen, how much carbon dioxide will produce and how much mass of water will produce? This is also gas now, this is also gas. So what is the third key point? The ratio of stoichiometry is the volume ratio of the gaseous component. What is the stoichiometry ratio? 2:1. So volume ratio must be 2:1. If it is 44.8, it should be half of that is 22.4 liter. Now we can see that volume ratio is 2:1 because stoichiometry is 2:1. Now we have to calculate the mass of water produced. So we don't have any mass ratio. We cannot relate the mass directly with the stoichiometry. First we have to relate the mole, and from the mole we can relate the mass. What will be the mole ratio of O2 and H2O? It will be 1:1 because it is 2:2. So we can say that 1:1. Okay. What is the mole of O2 in the presence of 44.8 liter? Mole formula is given volume in liter, divided by 22.4 liter. So given volume is 44.8 and 22.4 if we divide, we will get the 2 mole. So definitely 2 mole of oxygen will produce 2 mole of water because their stoichiometry ratio is same. So we will get 2 mole of water. Just we have to calculate in 2 mole of water what is the mass of water. We know that mass is equal to mole into molecular weight. So mass is equal to mole into molecular weight. What is the molecular weight of water? Is it 18? So it will be 2 into 18 gram. That will be 36 gram. It means on burning CH4 in the presence of 44.8 liter of O2, 22.4 liter of carbon dioxide gas will produce and 36 gram of water will produce. Thank you.